Now we are going to take a look at the Maven POM, or the build for the application. If you're not familiar with Maven, I have a Maven tutorial you can go through to get kind of the ins and outs, but to really summarize it, Maven is an XML file that's used for declaring plugins, libraries, and other types of common capabilities for building, running, checking, and testing an application. At the very top, we can see that we're actually pulling in the Spring Boot parent POM. This is so that we can have all of the dependencies from Spring Boot available to us specifically for version 3.2.3. The group artifact version and name is just identifying the name of the version of the underlying application, and in our case we're using some common properties for that we're using Spring Boot 3.2.3, but also we're running on Java version 17. The next section gets with dependencies where you're listing the names and versions of individual libraries that you're pulling into this project. In our case, we're using the appropriate version of Spring Boot, using Kafka streams for sending data and getting data out of Kafka. We're also using the Spring Kafka integration as well. And then for Cassandra, we're using its data stacks driver for communicating with a database, but also bringing in the annotations and other resources needed for Cassandra in a Spring Boot environment. We have general Spring Boot starter project, starter web for running web services, and specifically actuator, which is used for automatically creating a /health endpoint that will automatically detect most Spring integrated technologies like your database and display that as a part of an overall health page used for monitoring. Lombok has become pretty popular in Java. It's a means of using annotations for representing getters and setters. Typically, from a Java perspective, if I have a class and I have a member variable that's private, for example, name, I have to declare two public methods, one for getting the value of name and one for setting the value of name. Lombok allows you to use annotations to prevent having to create those additional 6 lines of getter and setter methods. We're using JUnit for unit testing, and otherwise we're specifying to use the vintage JUnit engine because we're using JUnit 5. As a final dependency, we're using something known as OpenAPI. This was formerly known as Swagger, and it's an automatically generated web page that works a lot like Postman in a sense that you can see all of your web services, all the descriptions you added through annotations, but also it allows you to interact with those web services. Next, we have a series of build plugins. The Maven site plugin is used for creating an actual entire HTML site describing all the aspects of your application from test coverage to static code analysis issues. The reports plugin is needed for augmenting the site plugin with some specific reports. We're using the Maven plugin because that's our build technology. We're using Jacoco for calculating code coverage, which you can also use to enforce certain types of standard. Generally speaking, in Java, I recommend enforcing above 85% line coverage, but since this is a demonstration project, I haven't written unit tests for everything, so I actually commented out those rules. More JUnit stuff. Finally, we have something known as the check style plugin. The check style plugin, it allows you to load a set of common rules. In my case, I'm using the check style rules from Google, which you can see defined here in this file, that's defining common ways that you should be writing Java code. The advantage of having this plugin is that if you have it turned on to enforce it, it prevents you from doing things that look like non-standard Java code. Everything from using non-Java file extensions to making sure that you're not having more than 100 codes on a line. We then have the PMD plugin, which is more about common coding practices for Java. That comes from a PMD XML file, which also came from Google, which gets into specific rules and practices you use for writing Java code, what we call standard Java code, where to put tabs, where to put spaces, not having try-catch blocks that have exceptions, blocks that you don't do anything, making sure you're not having too many static imports. This is all about writing standard Java code so that when two people approach a problem, even if they approach the problem differently, the code will still look the same, and it's really about readability and preventing common coding issues. The Spot Bugs plugin is more of the same. We're also using specifically the Find Security Bugs plugin, so this is going to look for additional common coding issues, but also include a security aspect to it. And in terms of formatting, for example, tabs, spaces, do braces go on the line or the next line? No need to worry about it. We have the Spotless plugin. When you run this, it'll actually format all of your Java code according to the Google format rules. This will actually reduce a lot of those PMD and spot bugs issues you would normally get, because a lot of it's dedicated to formatting, which is something that could be done in an entirely automated fashion.